Alright, the factor theorem. If a polynomial, p at x, is divided by x minus c, some constant, then the remainder will always equal p at that c. So here's an example. I give you p at x as 2x cubed plus 3x squared plus 2x minus 2. And then we're going to divide that function by x plus 2 and 2x minus 1. We'll just do it one at a time. And what you'll notice in this case is that when I plug in the root of those divisors into p at x, that'll give me our remainder. So let's first off find that root. So we got x plus 2. We'll just start with this one. So x plus 2 equals 0. If you solve that, we know our root is negative 2. So we're going to take negative 2 and plug it into p at x. So p at negative 2 is equal to 2 times negative 2 cubed plus 3 times negative 2 squared plus 2 times negative 2 minus 2. And if we keep on working that down, that would be 2 times negative 8 plus 3 times 4 minus 4 minus 2, which would be negative 16 plus 12 minus 6. And that should give me negative 10. Okay, which it does. Then, so negative 10 is, I know, is the remainder if I were to divide that polynomial p at x with x plus 2. So let's just check that with synthetic division. So my coefficients, just kind of going off of here, are 2, 3, 2, and negative 2. And the root I'm dividing by is negative 2. So when you do these, you bring down your first coefficient, which would be 2. You multiply these, that'd be negative 4. Add down is negative 1. Multiply again, 2 times negative 1. You get positive 2. Add down, you get 4. Negative 2 times 4 is negative 8. And negative 8 minus 2 is negative 10. And so we know we're always 1 degree less. So our quotient is 2x squared minus x plus 4 plus the remainder of negative 10 over x plus 2. And so we know that the factor theorem works for that one in that case. And so let's go ahead and try it for the second one, which was 2x minus 1. So in that case, 2x minus 1 equals 0. So you add 1, and so 2x equals 1, so x is equal to 1/2. So now we're going to use 1/2 and see what that remainder is. So again, we'll go ahead and find out what p at 1/2 is. So that would be 2 times 1/2 cubed plus 3 times 1/2 squared plus 2 times 1/2 minus 2, and that would be 2 times 1/8 plus 3 times 1/4 plus 1 minus 2, and keep working here. That'd be 1/4 plus 3/4 plus 1 minus 2, and that would give you 1 plus 1 minus 2 is 0. So cool. That means that 1/2 is a root of that original polynomial. So let's go ahead and do synthetic division on it. Same thing. You'd have 1/2 for your root. It goes 2, 3, 2, negative 2. We're going to divide. And so you bring down your 2. 2 times 1/2 is 1. Add down. That's I'm sorry, that's 4. 4 times 1/2 is 2. Add down is 4. 4 times 1/2 is 2. Negative 2 plus 2 is 0. So I know that when you divide our polynomial p of x by 2x minus 1, you get 2x squared plus 4x plus 4. Okay, and we could keep factoring this now. 2 and then x squared plus 2x plus 2. And now if you want the rest of the roots, it's as simple as finding a quadratic. It doesn't factor. And so you could find the rest of the roots to this, find out all 3 of them. And, it's probably irrational or possibly, well, if you do the discriminant, you'd have b squared minus 4ac. We'd know that you'd have 4 minus 4 times 1 times 2. And 4 minus 8, it's going to be a negative 4, so I know that the next 2 roots are going to be imaginary. So that's a quick method on how to find your roots and use the factor theorem to do it. So hopefully this helps. Good luck, and I'll catch you next time. Well, hold on. Let's go ahead and find the roots. Maybe that's freaking you out a little bit. What did he mean by more roots to this thing? So another couple of roots to this thing would be to go ahead and use quadratic formula. So x equals negative 2 plus or minus the square root of b squared minus 4ac, which we already know is negative 4 because of that, all over 2a, which is 2. And if you test that out, you get negative 2 plus or minus 2i over 2, and so x equals negative 1 plus or minus I, if you simplify that. So we have 2 roots to this polynomial, this p of x polynomial. 1/2 is a root, 1 plus I is a root, and, negative 1 plus I, and negative 1 minus I is a root. And so what's kind of cool, I know it's hard to imagine this because it's an imaginary number, but if you take negative 1 plus I and negative 1 minus I and plug that into p at x, you will also get 0 for those. And so my videotape isn't long enough to do that. It's going to take quite a bit of algebra, but you would get 0 when you plug those 2 roots in, showing that they come out even. All right. Hopefully that helps. That's about everything you need to know with the polynomial division. So good luck and see you next time.